Welcome to This Explainer. Okay, today we are diving into a biological feat so extreme, so seemingly impossible, that it completely shatters our understanding of endurance, physics, and physiology. We are talking about an athlete that literally makes our greatest marathon runners look like they're just taking a casual stroll in the park. Today, we are deconstructing the ultimate flight record. 13,560 kilometers, or for those of you using miles, that's about 8,425 miles. That huge number is the distance of the longest documented nonstop flight by any animal on Earth. We're looking at a point-to-point journey straight across the globe, going all the way from the freezing tundra of Alaska directly to the shores of Tasmania, Australia.
And honestly, here is the absolute kicker. 11. This entire journey took 11 solid days. That's 264 hours of continuous, relentless wing flapping. And keep in mind, unlike seabirds, like an albatross, the hero of our story cannot rest on the water. It can't stop to grab a snack at sea. If it stops flying, it drowns. It is one single, totally uninterrupted, nonstop flight.
Okay, let's dive into this, because the Pacific Ocean is essentially the ultimate ecological barrier. There are zero pit stops out there, absolutely no places to refuel. And the absolute most mind-blowing part of this specific record, the bird that pulled off this 13,560-kilometer journey back in 2022, a bird tracked by scientists and known simply as B6, was just a juvenile. It was only 5 months old. This was its first ever migration, and it did the whole thing completely solo, without a single adult to guide the way. No way, right?
Section 1. Built like a jet fighter. So, to even begin to understand how a crow-sized shorebird called the Bar-tailed Godwit can pull this off, we really have to look at it the same way an aerospace engineer analyzes an advanced aircraft. Just listen to this quote from Dr. Jesse Conklin of the Global Flyway Network. That's the consortium that actually tracks these epic migratory journeys. He says, "They are designed like a jet fighter. Long, pointed wings, and a really sleek design which gives them a lot of aerodynamic potential." I mean, this bird has literally evolved over millennia for extreme aerodynamic efficiency. Now, what's really interesting about this slide is exactly how this biological jet fighter is spec'd out. The Bar-tailed Godwit rocks a high wing aspect ratio of 9.3, meaning its wings are super long and slender, which heavily reduces lift-induced drag. It also has a highly streamlined body profile. And get this, at a microscopic scale, it actually optimizes turbulence in the boundary layer of air flowing over its body, practically eliminating drag from chaotic wakes. Finally, it maintains a remarkably high flight speed. And that's an absolutely crucial adaptation, so it doesn't just drift way off course when it gets slammed by intense Pacific crosswinds.
Section 2. Fueling the ball of bacon.
But hey, a jet fighter is nothing without fuel, right? When you're flying for 11 days straight, you need an energy source that is incredibly dense, but also light enough to actually carry. For the Godwit, that fuel is fat. Before they even take off, these birds enter a wild state called hyperphagia. For about 2 months, hanging out on the Alaskan mudflats, they just gorge themselves on clams, bristleworms, and snails. They essentially turn themselves into flying fuel tanks. They can actually double their standard weight, hitting up to 55% body fat. In fact, ornithologists playfully refer to a pre-migration godwit as a ball of bacon, because it's just packed to the brim with energy-rich lipids.
So the crucial point here is their burn rate. They burn a staggeringly low 0.41% of their body mass per hour. That is literally among the lowest fuel consumption rates ever measured for powered animal flight. To put that into perspective, some smaller migratory birds burn up to 2% of their body mass every single hour. The Godwit's efficiency is just off the charts.
Section 3. Eating organs to survive.
Now, packing on all that fat obviously creates a massive weight problem. To even survive, they have to undergo a bizarre mid-flight metamorphosis through a process called autophagy, which literally translates to self-eating. To maximize their fuel load, they have to ruthlessly eliminate any non-essential payload. So the Godwit actually consumes its own internal organs mid-flight. To make space for that fat and shed dead weight, the bird shrinks its intestines, its liver, its kidneys, and its gizzard. It sheds about half of its non-fat weight before migrating. And the most incredible part? Once it finally lands in New Zealand or Australia, it completely regrows those entire organs so it can start digesting food normally again.
And this brilliantly illustrates the data behind that metamorphosis. When we compare birds before departure and after arrival,
we see this dramatic drop in mass for the intestine, liver, and kidneys. For decades, scientists actually believed a migrating bird's airframe, its non-fat tissue, was totally static. But this proves that aside from the brain, the lungs, and the heart, a godwit's internal architecture is completely dynamic. They are literally digesting their own anatomy just to keep their wings beating.
Section 4. Beating human technology.
Let's move to and see how this builds up against human achievements, because it really puts our technological prowess into perspective. We often think of our machines as the pinnacle of efficiency, right? But nature has had a multi-million-year head start. Here we have the Bar-tailed Godwit stacked directly up against the world record-holding solar drone, the Kinetic Zephyr. Now, the Zephyr managed an incredible continuous flight of about 82 hours, so roughly 3.5 days, using external solar energy and a static, rigid build. But the Godwit? 8 to 11 days, relying purely on internal lipid reserves, dynamically altering its very organ architecture in midair to survive. This bird absolutely crushes our most advanced, state-of-the-art drone technology.
Section 5. The Unsolved Mysteries.
But despite everything we've learned from tracking these flights and dissecting their physiology, some really massive questions still remain. The biggest one? When on Earth do they sleep? Remember, we are talking about 264 hours of continuous flapping. Humans start hallucinating after just a few days without sleep. How does a bird maintain perfect muscle coordination and navigation without just falling out of the sky from sheer sleep deprivation? Well, researchers are actively using high-tech tags right now to measure their brain activity, trying to see if they're somehow sleeping on the wing, perhaps even shutting down just half of their brain at a time.
And then, of course, there's the crazy mystery of navigation. Seriously, how did our 5-month-old juvenile, B6, find a highly specific wintering spot in Tasmania on its very first try, flying totally solo over the featureless Pacific Ocean? Theory suggests an incredible suite of internal mechanisms. They might use magnetoreception, meaning they have an internal compass sensitive to the Earth's magnetic field. They might use celestial navigation to literally read the stars, or solar compasses sensitive to ultraviolet light to track the sun even through heavy clouds. Basically, they have a built-in biological GPS system that we just don't fully understand yet.
So the next time you look up at a flock of birds passing overhead, I really hope you remember the bar-tailed Godwit. Think about that 5-month-old ball of bacon that shrank its own organs, battled in intense Pacific crosswinds, and flapped nonstop for 11 days straight just to survive. It really forces us to ask, if the sky is harboring this kind of impossible biological magic, what other wondrous secrets is the natural world quietly hiding right in front of us?